Unit 4.1, Classifying Triangles. In this unit, we're going to classify triangles by angles and by sides. First off, classifying triangles by angles is an acute triangle, where all angles are less than 90 degrees. Equal angular triangle, all angles are congruent, which means their measures are equal. Since the angles of a triangle add up to be 180, each angle would be 60 degrees. Obtuse triangle, one angle greater than 90 degrees. Right triangle, 190-degree angle. In the pictures that you're given to solve a problem, they would have to tell you by this symbol that there is a 90-degree angle, or by words. Classifying the following triangles as acute, obtuse, equiangular, or right. The first one has all 60-degree angles, so it's equiangular. Second one has one obtuse angle, so it's obtuse. The next triangle has three angles that are each less than 90 degrees, so this is an acute triangle. Looking at the fourth picture, we can definitely see that we have at least one right triangle. So the obvious one is this one right here because of the notation. So we have triangle YWZ that's right. But this angle right here for the big triangle is also 90 degrees. So we also have a right triangle that's YXZ. If this angle right here is 90 degrees, it forms a line, so this one also has to be 90 degrees because they're a linear pair. So we have a third right triangle, YWX. So there's three right triangles. Next, we'll classify triangles by size. We have an equilateral, where all sides are congruent. Isosceles, which in this class will be the definition that we have only two sides congruent. And the third is no congruent sides. The first problem says if point Y is a midpoint of Vx. So Y right here is the midpoint of the segment Vx, which means that Vy is congruent to Yx, which means that the length of Vy is 4.2 and the length of Yx is 4.2. Next, it says that Wy is 3, so the length here of Wy is 3, and it asks you to classify Vwy as equilateral, isosceles, or scalene. Well, none of the sides are congruent. Vw is 4.5, Vy is 4.2, and Wy is 3, so this is scalene. The next problem asks us to find the measures of the sides of isosceles triangle KLM with base KL. So KL is a base. That means that the sides KM and LM are congruent. So KM equals LM, and that way we can solve for D. So Km is 4D minus 13. Lm is 12 minus D. Solving for D, we add D to both sides, then add 13 to both sides. So D is 5. They asked us to find the measures of the sides, so plugging it in, KL would be 5 plus 6, which equals 11. Km equals Lm, so plugging it into Lm, we have 12 minus 5, which is 7. Find x in the measure of each side of an equilateral triangle, which means that all the sides are equal to each other. So AB will equal BC will equal AC. And I'm going to pick BC and AC and equal them together. So BC is 7 plus x. AC is 13 minus x. Adding x to both sides, I'll have 2x. Subtracting 7 from both sides, I will have 6. So x equals 3. Now we know that AB equals BC equals AC. Plugging it into AC, I have 13 minus 3, which is 10. This next problem is one of the problems that's going to take a little bit more work. So here I want to find the measures of the sides of angle KPL and classify the triangle by its sides. So I have to find KP, PL, and KL. To do that, I need to use the distance formula, which we studied in Unit 1. It's the differences in the x's squared plus the differences in the y squared. And then we take the square root of that. So looking for the distance KP, I would take the differences in the x's and square them, plus the differences in the y's and square them. When you're showing your work on any assessment, homework, group assignment, you need to show that step. Next we have -2 plus 4, which will give us 2 squared. And then -6 minus 0, which is -6 squared. So we would have 4 plus 36, which give us rad 40. So I need to see this step and this step also. Next, let's do PL. Differences in the y squared plus the differences in, the differences in the x squared plus the differences in the y squared, which means that we'll be squaring -7 and squaring 1. Which will give us rad 50. I want you to leave them without putting them in the calculator and getting a rounded answer. And Unit 5 will work on simplifying radicals. The last one we have to look at is KL. Differences in the y's, the differences in the x's squared plus the differences in the y squared. Should give us -5 squared plus -5 squared. So we have two sides where the measures are equal, so they're congruent. So this triangle is isosceles. In Unit 1, we reviewed simplifying rational expressions. We're going to continue to do that because it's a necessary skill that we need. If I look at 15 and 25, 5 goes into both of them. 5 goes into 15 3 times. 25 divided by 5 will give us 5. Looking at the x's, there's two ways to do it, or two ways to think about it. This would be x to the 4th minus 9, which is x to the negative 5, which is 1 over x to the 5th. So x to the 5th will go on the bottom. You could also look at it as there's more x's on the bottom than there is on the top. So when you subtract them, it will go on the bottom. Looking at the y's, there's more y's on the top. So we have y to the 21st power minus 16, which will give us y to the 5th, and that lives on the top. For the second problem, we have to factor. So we're looking for the factors of negative 10 that add up to be 3. 5 times 2 is 10. So 5 plus negative 2 will give us 3. So this is factored as x plus 5 and x minus 2. So I'm not asking you to solve x squared plus 3x minus 10 to find what x's there are. I'm asking you to factor it and then show or use that factoring. For the denominator, we can factor out a 2. So I'm left with 2 times x minus 2. My final answer would be x plus 5 over 2. And that concludes the lesson for 4-1.